Hello folks, today we're going to go over the 20s, which is also known as the Elmo sheet. I'm going to go through this kind of fast. I would encourage you to pause as we're going along. That way, you can give yourself a chance at each of the questions, but to get through it in a timely fashion, I'm just going to display, you pause, display, you pause, and write down stuff as we're going along. So a solvent is a substance that dissolves a solute. It's the majority component in a solution. In other words, it's the thing you have the most of. And in layman's terms, you would say the solvent is the thing that's doing the dissolving, or you might call it the dissolver. Again, stop the video, write it down, and then start playing from there. What is the universal solvent? A solvent that dissolves more substances than anything else. That would be water, and in this unit, water will be the solvent that we talk about the most. Solute is the substance that's being dissolved, and it's also the minority substance in a solution. In other words, like you put sugar into a glass of water, the sugar would be considered a solute. It's the minority substance, where water is the majority substance, and therefore it would be called the solvent. What is a solution? It's a solute and a solvent put together. Homogeneous means it is the same throughout. So if you make Kool-Aid the right way, it is the same from the first glass to the last glass. And that's called homogeneous or homogeneous. If you make Kool-Aid the wrong way, you end up getting a whole bunch of sugar down on the bottom, and that's what we call a heterogeneous solution. It is not the same throughout. So right here we have salt water. The salt is completely dissolved in the water. And no matter if you take a drink from here or here or here, it is the same throughout. That would be considered homogeneous or homogeneous solution. Chocolate milk, if you put a bunch of scoops of chocolate powder into a glass of milk and maybe some of the powder goes down to the bottom, and when you're sucking up with a straw at the very end, you suck up little chunks of powder that didn't dissolve, that'd be a heterogeneous mixture. A real heterogeneous mixture is this one over here, where it's the mixing of oil and water. It is not the same right here as it is right here, as it is right here, as it is right here. It is different throughout, and that is what a heterogeneous mixture is. So heterogeneous is different, and homogeneous is the same throughout. Ionic compounds are made from a metal and a nonmetal, a metal and a polyatomic ion, a polyatomic ion and another polyatomic ion, or you could write cation and anion. Again, stop the video so you have time to write in these items. Ionic solutions are made when an ionic compound dissociates in a solvent. Dissociates means to break apart. So if you associate with other people, you are with other people, and if you dissociate yourself from them, you are removing yourself from them. What is an aqueous solution? So agua or aqua mean water. So an aqueous solution is where the solvent is water. Water will dissociate or break apart ionic substances. And aqueous solutions or aqueous solutions are ions in water. So most of the solutions in this unit will be aqueous solutions, and you'll start to see that show up in problems. So in this problem we have some lead-2 acetate dissolving in some water. What's the solvent? Pause the video, try to figure out what's the solvent between lead-2 acetate and water. Hopefully you realize that the solvents we're talking about will be water, and lead-2 acetate would be the solute. When you put lead-2 acetate, a solid lead-2 acetate, into water, it will dissociate, and this is what you'll get out of it. We get lead ions, and we put an AQ, meaning dissolved in water, and then we get 2 acetate ions, and we put AQ, meaning dissolved in water. What is an aqueous solution? It is a solution containing water as the solvent. This shows dissolving. In this problem, we have a salt crystal or a bunch of salt thrown into some water. And what we need to realize about water is that the hydrogens, that's these little spheres right here, have a slightly positive charge on them, and the oxygens have a slightly negative charge. So when you put an ionic compound like salt into water, all the slightly negative charges of these oxygens are attracted to this positive charge of the sodium, and it effectively rips it out of the crystal. All these positives on the hydrogens are attracted to this negative chloride. So there's an attraction there, an attraction there. And then what that happens is they surround this chloride, and it effectively rips it out of the crystal. And that keeps happening until all the water molecules have been used up, or all of the ionic substance has been ripped apart. This is just another view of the exact same thing. So now we want to write the dissociation reactions for these substances. Try them on your own. I'm going to reveal them, but try them on your own first. So there's the first one, the second one, the third one. Hopefully you paused the video as you were going through it. So in this problem, which cup of coffee, we have 2 cups of coffee, and it's asking what is the solute and what is the solvent. So in a cup of coffee, the solvent would be water, and the solute would be the coffee grounds or the coffee beans. Which cup of coffee is more concentrated? Well, hopefully you can see the one on the right is a lot darker, therefore it would be considered a more concentrated cup of coffee. Which cup of coffee is more dilute? Well, the one on the left looks more watery, less dark, and therefore it would be more dilute. Which cup of coffee has more grams of solute in it? Well, hopefully you can see the one on the right is darker, and therefore probably has more solute dissolved in it. Which cup of coffee has more moles of solute? Well, if the one on the right-hand side had more grams of solute, and you can convert grams into moles, it would also have more moles of solute. So the one on the right-hand side has more moles of solute. This is the first thing that we really need to teach you for this unit, and it is molarity. It's how we're going to talk about a lot of our solutions. It's represented by a large M, though usually the large M will not show up anywhere in the problem except for maybe the answer. The large M stands for moles of solute divided by liters of solution. So which cup of coffee has the highest molarity? Think about it, pause it. The one on the right-hand side has the highest molarity. It has the most moles of solute per liter of solution. Flip your page, obtain a calculator, obtain a unit pack cover, and we're going to go through some of the materials. So here we're going to calculate the molarity when we have 3 moles of sodium chloride dissolved in enough water to make 2.5 liters of solution. Why don't you pause the video and see if you could do this problem on your own before you watch me do it. So in this problem we have 3.00 moles of sodium chloride, NaCl. That's the moles. And liters of solution, we have 2.50 liters of solution, and this is how we represent solution. You do the math on that, and you find out that that is 1.20. That'd be moles per liter or molar. So that's about the only time that the big M actually shows itself in problems. There are 1,000 milliliters in a liter. And on your cover, you have a heart, you have an arrow, you have a triangle for liters, and you have a triangle over here for milliliters. Well, the bridge between milliliters and liters is 1,000. There are always 1,000 milliliters in 1 liter. Make sure you put that on your cover. Number 20. You have 60 grams of sodium chloride dissolved in enough water to make 2 liters of solution. What is the molarity? Again, we need moles and we need liters. Well, in this problem, we're given grams. So the first thing we have to do is convert those grams into moles. Pause it, see if you can solve this problem, and then turn it back on and watch and see if you are successful. So we got 60.0 grams of NaCl. Multiplication sign, division bar, grams of NaCl go down here, and then moles of NaCl go on top. There are 58.44 grams in 1 mole, and if you solve that, you end up getting an answer of 1.03 moles of NaCl. So this problem, that is the mole value. That number is going to go right there. And the 2 liters is going to go right there. And when you solve it, you're going to get 0.52 molar. Next, we're going to talk about how to make a solution. You can't see this, but a volumetric flask looks something similar to this. And that's what we're going to use for making it. So in this problem, we're going to get a proper size volumetric flask. So we would get a 2,000 milliliter volumetric flask. We would fill the flask half full with water. So you fill it half full with water. We would add our certain grams, our 60 grams of NaCl. We would swirl it around until the solute has dissolved. We would then fill the volumetric flask to the line, so we would add water all the way up to that line with water. And then we would flip it back and forth, upside down, right side up, about 12 times. That's how long it takes to completely make it a homogeneous solution.